Hey guys, happy Friday. Today I'm going to be running through a solid acid lab, an unknown solid acid lab is what I've titled it. So what I'm going to do in order to run this is I am going to be running a titration. I think you can maybe see it off to the side here. I have a burette and a ring stand set up, and I'll be running a titration on a couple of solid acids. Now, these solid acids are listed in my presentation, okay? And they'll say what they are, but effectively I'm just going to run a couple trials of each, and you don't know which one is which, and it's going to be the data that's going to help you determine which is which. Okay, so I'll have an unknown A and an unknown B, so to speak. And I'll run 2 trials or 2 titrations on each. I'll give you that data, and then what I'd like you to do with that data, and again, I will explain more of this as we go here. I got my computer off to the side. Give me a second here. Okay, so what I'd like you to do with that data is I would like you to show me the factor label math to determine the molar mass of each of the solid acids. Okay, now I'm running 4 trials, 2 trials of A, 2 trials of B. I would like 1 factor label problem for A, 1 factor label problem for B. So I want to see 2 factor label problems in total for everything I give you today. Okay? So, on a separate piece of paper, I don't have a handout for this one, so for those of you who have been printing the handouts that I've been giving on Fridays, I don't have one for you today. On a separate piece of paper, 2 factor label problems, 1 for A's data, 1 for B's data, and then I would like a net ionic equation for both reactions. So we have acid-base reactions going on today. The base I'm using is sodium hydroxide, NaOH. That'll be one of our reactants. NaOH is a strong base, so we will have to dissociate that in our net ionic equation. The acids are actually salt. Okay, we'll talk about acidic salts and basic salts next week. But acidic salts are just like any other salt, meaning if they dissolve in water, which these do, they're going to dissociate. So we'll look at that too, and I will give you some guidance and I will give you some help in terms of getting a net ionic for both these reactions, because it's a little tricky. So anyway, what I'm going to do, I have some more information there. So the 2 unknown acids, or the 2 unknown solid acids, which are really salts, I have potassium hydrogen phthalate, which is KHC8H4O4, and then I have potassium bisulfate, KHSO4. The base I'm using, like I said, is sodium hydroxide. I have a solution of it in this jug right here, and it is 0.195 molar. Okay, so that's the molarity of this. This is going to be our titrant. This is what I know. It's going to go in the burette. In the Erlenmeyer flask, okay, down below, I'm going to put between 0.4 and 0.5 grams of my unknown acid. I'll start with A, do 2 trials, go to B, do 2 trials, and give you all that data to allow you to do those factor label problems. Okay? So, I'm going to get set up. I'll be right back in just a second. Obviously, it's instantaneous on the video, so when I say that, I don't know why I say that. Anyway. All right. So, let's see if I can get the computer off of here so you're not watching yourself. Or you're not watching me twice. That sounds awful. Watching me once sometimes is enough, I'm sure. Anyway, so what I'm going to do now is I'm going to get the mass of my unknown acid. Okay? So this is unknown acid A. I'm going to try not to show you what the heck it is. But let's use our balance. I'm just going to measure it right into my Erlenmeyer flask. I could measure it into a different like little tray or a container and then transfer it to the Erlenmeyer flask, but there's a chance that I'm going to lose some of it along the way, and I don't want to take that chance. So I'm going to just measure it directly into my Erlenmeyer flask. So I have, I'm going to tear that so it's down to 0, and then I'm going to take my unknown acid, and I'm going to add between 0.4 and 0.5 grams. Now, it doesn't really matter how much. What does matter is that I record it. Okay? That's the important part. So, let's record it. Let's get what we need and write it down. This is definitely going to spill. There we go. And I overshot it just a smidge. Doesn't take much, but that's okay. This is going to be what we can record. I got 0.506, okay, 0.506 for my first mass, for my first titration. So now, let's take this, and I'm going to flip the camera here, and let's get set up to run a titration. So, what I have is, let me see if I can get a better angle here. I don't know if I really have a great angle. Oh well, we'll try our best. But I'm going to now add my base to the burette, and what you want to do with this is you do want to flush the burette. Now this burette's been hanging out, sitting here for, I don't know, a year and probably hasn't been used. So there's probably nothing in it, but just for the sake of argument, it's a good idea to do one rinse of the burette to make sure that there's not residual stuff in there screwing up the molarity of what I'm adding. I want the molarity to be exactly what I think it is, and that's 0.195. All right, so I have my base, and I'm going to do one flush with the burette. Now, I almost just screwed it up. If you look at my burette, and I'll turn it towards you, okay? When this is when this is parallel to the burette, it's going to be flushing out, and it's open. That's not good. If I don't have anything here, I'm just going to end up with a whole bunch of base on my countertop. Let's not do that. I'm going to close it, and now I'm going to add my base. So what I'll try to do here is I'll try to show you what I'm up to. Up top, oops, sorry about that. Up top, I have a funnel, which I think you can kind of see, and I'm just going to pour this in there and be careful not to overflow it. I always tell my AP kids when they're actually in lab that you're not a true chemist unless you overflow a burette. This is very easy to do. So I'm not going to do that. I filled it up almost to the top. I think you can see the level there. And now I'm just going to flush out the burette, okay? I have a little bit of base left in here. I'm going to dump this when I'm all done. So I'm going to let this just empty out into my beaker. I'm going to lower this just a bit so I'm not getting too much splashing. And I'll open this up. Now, there was a bunch of air bubbles that came running through, okay? And I want to get those out. So I'm going to try my best to kind of open it, close it, and really kind of, mess with it a little bit because we really want those air bubbles out. They mess up our data. So I'm going to empty this completely, and then I'm going to refill it. Now, the reason why you want to rinse it, like I kind of said a little bit earlier, is I don't know what's been in here, and I don't know what's still in here, right? So in an ideal world, there's nothing, and it's clean, and that's all well and good, but sometimes it's just not. So I do a good rinse with what I'm actually going to use as my titrant, to make sure that when I actually run my titration, the molarity that I think I have is the molarity that I actually have. So this is almost done rinsing. I will then dump this out because that's been tainted or potentially messed with as it's been in my burette. I'll get some new stuff and then I'll fill it back up and then we'll get ready to set up and run our titration for real. Okay, now another mistake is sometimes there's a bubble down here. Okay? I rinsed this, and I think you can even see it actually. I rinsed this, and I opened it up, and I let it drain completely. But now, if I want to run my titration, I don't want that bubble there. That's going to screw up my volume. So I need to let that clear out. There we go. Now it's primed. Now it's primed, and I can read my volume, and I can start my titration and be confident that whatever volume it says that I'm adding, I've actually added. So here we go. I have done this. My burette is now filled with sodium hydroxide, and we can begin our first titration. Here's my 0.506 grams of unknown acid A. However, I don't want to run the titration just into the solid acid. I want to dissolve this first. Now, this is a little funky. This is just distilled water in this bottle, by the way. But it doesn't matter how much distilled water I add, because this is the same number of moles of acid regardless of how much water I put in there, right? Whether I add 20 milliliters or 50 milliliters, guess what? It's still 0.506 grams. So the moles of acid don't change regardless of how much water I use to dissolve it. So I'm just going to pour some in there. There, perfect. I'll give it a swirl to try to dissolve it as best I can. But the cool thing with this one is even if it all doesn't dissolve right now in the water, as I add the base, more of it will start to dissolve, because as the acid and the base react, more of the acid it'll dissolve easier as more acid reacts with the base. So over time, even if I start my titration without all of the acid being dissolved. By the time I'm all done, as long as I'm swirling it and keeping an eye on it, it will all be dissolved and all of it will react with the base that I'm adding. So I'm going to raise this up just a little bit so that the burette is just right at the lip. Now, if you're on a titration, you probably want to add an indicator. This is phenolphthalein. If I don't add indicator, I'm going to see a whole lot of nothing, and my data is not going to make any sense. So let me add 1, 2, we'll do a third just to be sure. 3 drops of phenolphthalein. Okay, I'll swirl that up. Raise this up just a smidge more. There we go. And now another tip. Okay, it also helps to have a piece of paper under your flask, because what we're looking for is pink, right? We know this titration is complete when my phenolphthalein changes color. Currently, I added the phenolphthalein to a solution of acid. I'm adding base. It's colorless, but as I add base, it will eventually turn pink. Now, when it turns pink and it stays pink, that means that I've reached the equivalence point, and that's when my titration is all done. So let me grab a piece of white paper and slide that underneath. Okay. Perfect. Now I can see it a little better, and I think it'll show up a little better on the video too, hopefully for you guys. All right, so I got my acid in the flask, I got my base in the burette, I'm ready to go. First things first, I need to record and write down my starting volume, because I need to know how much base I add in order to solve this problem. So let's do that. Let me read this. I am starting with 3.79. 3.79 milliliters is my starting value. You should record that, much like you should record the 0.506 grams of solid acid. Okay, we need both of those numbers to solve this. So I'm starting at 3.79 milliliters. Let's get this thing going. You can see pink. Okay, let's be a little careful here. When I swirl it, it goes away. Okay, it's not mixed, right? So if you can see the pink on the screen, I hope you can. I think you can. Yeah, you definitely can. All right. It's looking like it's trying to be done, but when I mix it up, it goes away, right? So once we do one trial, the second trial will be much quicker. I'll try to be good either way and make sure that we're not overshooting it this first time. Let's see how fast I can do this without screwing it up. It's hard to tell if it's close or not. And you know me, I didn't do any math beforehand. Ooh, I think it's getting pretty close. Now I'm going to use this technique, okay? And I would show you this if you were here. Instead of just opening it up and trying to get one drop to drip, if you do a quick little half turn, it actually is less than a drop. So that is less than a full drop. Okay? And I'll do that a couple times. I think I'm still a smidge away. I'm going to go a little slower. It's not far, though. I can feel it. This is the excitement of titration. It's playing with the end point here. Oof. Thought it was going to stay. Okay, now we got to be careful. Don't worry, I won't make you watch this every trial. Maybe I should. Oh, so close. Oh. There we go. Now, don't let the color fool you, okay? It looks a little dark pink, but you saw how little I added between when it went back to colorless and when it turned pink and stayed pink, right? So the color of pink doesn't tell you how far or how much you missed the endpoint by. It just matters that there's pink there. The color of pink is 100% related to the concentration of phenolphthalein, not how far off or how much base is in there, okay? So we're all done. Now, we need the final volume. How much did we add? We started at 3.79 milliliters, and we have ended at 16.52 milliliters. Okay? So how much volume did we add in the first titration? Well, 16.52 milliliters is the end, subtracted 3.79 milliliters is the beginning, and that gives you your total volume of base added. And now we could use that to do a factor label problem. So here's what I'm going to do. I'm going to set up a second trial, run it. I won't record it, okay? And then I'll give you the data for both trials of the unknown acid A. All right, I am set up for my second trial of unknown A, okay? And what I have is the mass. I already put this in water, so my unknown solid acid I've already massed out. The mass of the second trial was the exact same as the first trial. I was nice to you. I could have given you different ones, but I figured whatever, I'll try to get it perfect. So I have, again, 0.506 grams of my unknown solid acid A. Now, I have my burette. In the previous trial, I went from 3.79 down to 16.52. I still have enough base in this burette that I don't need to refill it. I can just start my next trial exactly where I left off the previous trial. So I'm going to do that. My next trial is starting at 16.52 because that's where I left off and that's where my burette is currently at. So I'm going to run this. I won't bore you. Well, maybe I will bore you. Forget it. I'm quicker now. I know that it's going to be roughly like 13 milliliters, right, from my previous data. In the previous trial, it took 12 point something milliliters. So I know that I can probably just open this up and let it get down to about 10-ish, 11-ish milliliters before I really have to start being careful. So let me just open it up. Now, let's see how good of a chemist I am. You see how bright pink that is? Okay. Keep watching. I have confidence. There it goes. Okay. So it looked like it wanted to stay pink, but here was the deal. All of that solid acid wasn't fully dissolved. So that's what I was talking about earlier, right? That solid acid needs to be dissolved in order for it to be able to react with my base. So I knew that from the first trial, it took about 13 milliliters. I had just added about like 10 and a half right there. And I wasn't too worried because I knew exactly how much I should need from the previous trial. I'm swirling this to make sure all my solid acid dissolves. There's still a little bit left in there. We'll keep going here. Add another milliliter or two. And again, this should be safe because of the math that I've done previously. I know that this should be a safe amount still. It's getting a little more dangerous. Okay, now we're really in the danger zone. Let's slow down. Ooh, it's close. That's got to be it. Yep. Oh. I don't know. I can still see pink. You might not be able to see pink on your screen, but I can still see the faintest little bit of pink. Oh, it's getting fainter, though. Let's try one more squirt. Ugh. Now it's going to be pink. Yep, there we go. All right, so my second trial for unknown A. I started at 16.52, and I have ended at 29.39. 29.39. Yep, perfect. Sweet. So, I'll get you all that data for A. Let me set up B, and then we'll do a couple more, and then we'll be good to go. Okay, first trial for B, unknown solid acid B. I have a mass of 0.521 grams. I overshot it a bit, but that's okay. 0.521 grams for the mass of the first trial of B. Now, I still have a burette. I still have plenty in here. I'm not going to refill it. I'll refill it when it's getting close down to the bottom. So I'm starting at the same place I left off with the second trial of A. I have 29.39 milliliters in my burette as my starting point for trial 1 of unknown B. Here we go. V looks like it's a little more difficult to dissolve. A little bit larger crystals. You can't see it obviously on the computer screen, but maybe you can actually. Here, I'll try to get closer. Okay, if you can see the crystals in there, maybe you can't. I don't know. But a little bit larger crystals, so the dissolving of this one might be a little more tricky. Looks like this one's going to take more base than the first one, if I'm guessing. It feels like it's going to take more base. Yeah, I think it definitely is. Yep, without a doubt. Uh-oh, hopefully I have enough in here. Getting all smart about not having to refill my burette. Gonna come back and bite me, it looks like. Yeah, maybe not. How are we looking? I think all my solid acid is dissolved, so maybe I might be okay here. Oh, I hope so. I'm racing towards the edge of a cliff. See if I can salvage it before I go off the edge. I got about 5 milliliters left before I got to refill this thing. And I don't want to refill it mid-titration. That's a pain. You can do it, though. Nothing wrong with it. If it goes down, I don't want it to go below 50. There's the 50 mark right here. If it goes below that, I have no clue how much I've added. But if I keep it above 50, I could just record, right, where I stop. And then I would do the same thing. So I'd have like 2 pieces that I would need to add. I would have a start and a stop from the first time, and then I would have a start and a stop from the second time, and I'd just add those together to get my total volume. That's perfectly fine. Not necessarily ideal, but we'll see if we can avoid it. I think we can avoid it. Yeah, we're going to avoid it. I think. I think we're okay. Got about 1.5 milliliters left. Oh. Oh, it's so close. All right. Made it. Good deal. So, I didn't have to refill it. How exciting. 49.08. 49.08 is the stopping point. So this one's taking more. Okay, that first one only took around 13 milliliters per trial. This one took about 20. So now I know when I refill it, I better have at least 20 milliliters left if I run a second trial of B. So let me get that set up. It looks like it turned back to colorless though. Hold on. Scratch that 49.08. Let's get one more little pop in there. Ugh. There. Now it's big. Okay. So instead of 49.08, how about 49.10? That's all I added. I added 0.02 of a milliliter by that little quick half turn. It's the best method. It works really, really well. So instead of the 49.08, 49.10. All right, let me set up trial 2 for unknown B. We'll get all your data. We'll do a little bit of some net ionic stuff to make sure that you understand how to do that. And then we'll send you on. Okay, here we go. Trial 2 for unknown acid B. I have 0.609 grams. That's more than I wanted, but again, I'm just kind of, it doesn't really matter. I just know now if 0.521 grams of unknown B required around 20 milliliters, if I have 0.609 grams, I know it's going to take over 20, right? So I can be a little reckless here because I know how much, it needs at least 20, right? Just mathematically speaking. So let's see where I'm starting. I refilled my burette just a little bit to make sure I have enough. I'm starting at 17.31 milliliters. Okay? And let's just open this thing up. I know I can go to about 37, which is 20 milliliters, because the last one took 20 milliliters, and I had less acid in the last one. So I'm just going to let her fly. And this scares people, right? This looks scary to people that don't know what they're doing, because I'm just letting it go and it's bright pink and it's bright pink and it's bright pink and it's like, oh my gosh, I think you missed it. You overshot it. No, I haven't. I'm good. I'm good to go. All right, 37. There you go. Pinker than pink. You ready? All gone. Right? Because it's the math. I know what's going on. I know that I can confidently add 20 milliliters to this and not have any issue. Okay? Let me keep going. Gotta be a little careful now. Getting close. Maybe not that close. And you'll notice that I kind of do like these slow half turns and these faster half turns. I do a slower one when I know I'm not like right on top of the end point, and then I'll do those quick ones when I know I'm getting super close. So that's just a technique. Again, I'd like to have you try it, but not the world we live in, unfortunately, at the moment. Oh, come on. It's fighting me. Now we're on it. There we go. Maybe one more. One more. All right, one more. There we go. Okay, so we're there. I have reached the end point of the second trial. Let me just make sure I don't have any solid acid in here. No, it's all gone. I think it's going to go back to colorless. It's trying. That's still pink, though. Again, you can't see it probably on your screen, but it is still pink. That's still pink. All right, I'm not going to add any more. My volume ending is 39.86. 39.86 milliliters. Cool. So I have all the data. I'm going to switch over to the smartboard now, give you guys some more notes, and then I'll send you on your way with your objective for this lab. Whoops. Okay, so let me recap what we did. All right. In this lab, I have 2 unknown solid acids. Now, the formulas for those solid acids are in the middle of this slide. Okay, I did share this presentation with you on It's Learning. So the formulas for these solid acids are right here. One of them is A, one of them is B. The goal is to figure out which is which by solving for the molar mass of these through the data. Now, we know what the molar mass is off the periodic table, right? We should be able to find that pretty easily. We just add a potassium and a hydrogen and the rest of the stuff, right? So with that, we can compare it to what we get for the data. When we get a similar molar mass from the data that we did from the periodic table, well, that's what it is, right? Then we figured out our unknown. So that's the goal. So we have 2 acids to choose from. One is A, one is B. The base I used was 0.195 molar sodium hydroxide. And here's what I want. I want factor label problems, 1 for the A, 1 for the B, solving for molar mass. And I want a net ionic for each. So let's deal with the data and the factor label math just first, okay? So here is your data. I have not filled in the last column here, which is the total milliliters added. However, very easy. That is ending milliliters, subtracting starting milliliters. Okay? So I'm not going to do the subtraction for you. You can do that yourself. These are all the numbers that I said a while back in the video. I hope you maybe recorded them then. If you didn't, here they are right now. Please pause it and get what you need, obviously. But let's go to a blank slide here and set up some factor label math. Okay? So, I have the end goal is to solve for the molar mass of acid. Okay, that's the goal. What do we know about the base, right? Whenever you want to solve for the acid, we start with the base. So what do we know about the base? Well, we know that our molarity of base is 0.195 molar sodium hydroxide. That's half of what we know. What's the other half that we know? We also know the milliliters of base. Okay? We know two things. Don't start with molarity, right? That's what I said the other day. We don't want the molarity to start a factor label problem. It makes it a little harder. So let's start with the volume. You're going to start your factor label problem with milliliters of base. You need to convert that to liters. You then go from liters to moles. And last but not least, you would need to convert moles of base into moles of acid. And we don't know the acid, right? So when you don't know the acid, or you have an unknown acid, you can use a generic formula. I'm just going to write HA. The H is the hydrogen ion on an acid. The A is some generic anion. It doesn't matter what it is, okay? Because we don't know. Remember, we don't know which acid is which. Now, the good news is this is 1-to-1. Both of the acids that I've selected have one hydrogen for every one hydroxide of the base. So this is a 1-to-1 ratio. I will give you that. Now, when you solve this, what do you get? You get moles of acid. What do I want? I want molar mass when it's all said and done. Well, I have one other piece of information that I know from the data, don't I? I also know the grams of acid. What's molar mass? Grams per mole. The factor label math gets you to the moles. The grams comes from the data. If I take grams of acid divided by moles of acid, this equals my molar mass, right? That's how you're going to do the math. I'd like you to do one of these for A, one of these for B. I don't really care which trial you pick. Both trials should be good for both unknowns, okay? What I want you to do with that molar mass is compare it to what you get off the periodic table. If it's close, that means that that's probably the unknown, okay? It's not going to be perfect. This is lab data. I took real data. I didn't give you fudged fake data and try to fit it into a, make it work perfectly. It's real data, so it should be close, but probably not perfect. Now, the next part I want net ionic equations, okay? With net ionic equations, remember, anything that's ionic or anything that is strong, we dissociate. So what were our two reactants? Our two reactants are, I'll use the real formula here. Let me go back. Okay, I have potassium hydrogen phthalate, KHC8H4O4. Okay, that's aqueous because we dissolved that in water. That was the solid stuff. I added it to the flask, but then I dissolved it in distilled water, so I made it aqueous. The other reactant is sodium hydroxide, also aqueous. Here's the deal. This is a salt compound. It's strong. This is a strong base. They're both strong. I need to dissociate them. And when I do that, what I'm going to get is I'm going to get potassium ions, and I'm going to get hydrogen phthalate ions. This big giant thing is one individual polyatomic ion. Okay? So that's how I dissociate that first acid. You know how to dissociate sodium hydroxide. Here's what we have then. The hydrogen from this chunk is the acid. Do you see that first hydrogen written out front? Kind of like I described to you in Thursday's class. When you have a hydrogen out front, that means it's an acidic compound. Okay? So here's my acidic hydrogen out front. The rest of this will be left over. This hydrogen will react with the hydroxide from the sodium hydroxide. And be very careful. Okay? What I'm going to be left with over here is C8H4O4. Currently, HC8H4O4 has a 1- charge. If I take away another hydrogen, what's the charge of what's left over? I'll let you answer that for me, okay? So this is what it's going to look like. These are my two reactants up top. I dissociate them both. I get my products. I'll get some water, and I'll get half of a salt. I'll be left with this C8H4O4 as the other product, okay? For the other reaction, my other solid acid was potassium hydrogen sulfate or potassium bisulfate, okay? This is aqueous because we dissolved it in water. Again, it was solid at first. I then added distilled water to make it aqueous. I'm still using sodium hydroxide as my base. This is a salt. That's a strong base. They're both aqueous. I need to dissociate both of them. This one, when it dissociates, will be the same as the phthalate one. I get potassium ions, and I also get bisulfate ions. Okay? Now, the same thing's going to happen here, right? I have this as my acid. The potassium got dissociated, and the anion contains a hydrogen. This hydrogen is my acid, and it will react with the hydroxide of my base. When this bisulfate reacts with the NaOH, the H and the OH come together to make water, and the SO4 is not going to be HSO4, it'll just be SO4. HSO4 has a 1- charge. If I take a hydrogen away, SO4 has a different charge. All right? That's all I have. I know it was a long video today. I hope this is successful for you. Best of luck. If you need some help, shoot me an email. I'll be around all day Friday. Thanks, guys.